this lesson, we'll be discussing slope-intercept and how it's different from direct variation. By the end of the lesson, you should be able to find the slope and y-intercept of both proportional and non-proportional relationships and differentiate between slope-intercept and direct variation equations. So the slope tells us the rate of change, what keeps happening over and over. It also tells us how steep the line is and tells us the direction of the graph, meaning positive or negative. So remember, the slope is the change in y over the change in x. So in this table we can see that the y goes up by 4 and the x is going up by 1. So my slope is 4 over 1, which simplifies to 4. In this one, going from one point to the next, it's going up 4 and right 6. So my slope is 4 over 6, which simplifies to 2/3. The y-intercept is where the line crosses the y-axis. In a word problem, it's the beginning amount or initial value or startup cost. And it's also when x equals 0. So you can see in this graph, the red line crosses over the y-intercept right there at 2. So that point would be 0, 2. So my y-intercept is 2. In the table, we can see where x is 0, y is 1, so that means our y-intercept is 1. So the difference between the direct variation and slope-intercept, the direct variation is proportional, so that means it always begins at 0, 0. And slope-intercept is non-proportional, so it begins at some other point. So from this table, if I want to see the y-intercept, it's when x equals 0. But here I can't see when x is 0, so I'm going to have to work backwards. So seeing that the y is going up by 10 and the x is going up by 1, if I go backward from 10, backward 10 to 0, and 1, backward 1 to 0, so my y-intercept is equal to 0. So that means this is proportional or direct variation. In the second one, my y is going up by 5 and my x is going up by 1. So if I go backward, 15 minus 5 is 10 and 1 minus 1 is 0. So this time my y-intercept is 10 and it is non-proportional, or using the slope-intercept equation. For example, in your examples, find the y-intercept and slope for each graph and identify whether it's direct variation or slope-intercept. So you can see in this graph, it's beginning over here at 20. So my y-intercept is going to be 20. And my slope, I'm going to take 2 points. It goes up 4, right 2. So 4 over 2, which simplifies to 2. This one is slope-intercept because it does not begin at 0, 0. This one does begin at 0, 0, which means it's direct variation. My y-intercept is 0, and my slope, pick 2 points, up 6, right 5, so my slope is 6 over 5. Again, it is direct variation. Find the y-intercept and slope for each situation. Identify whether it's direct variation or slope-intercept. So our first example here says Van Lines is a moving company that transport family belongings across long distances over 250 miles. The cost is $10,000 to pack up and load the furniture on a truck. In addition, they charge $15 per mile to pay the driver and buy gasoline. So this situation, our slope is this per mile. Okay, that's one that keeps happening over and over and over. Our y-intercept is the beginning amount, so they charge $10,000 just to start. So since we have a starting that's bigger than 0, that means it's slope-intercept. The circus is coming down to town in the spring, and there'll be over 100 different animals performing. The cost of a ticket is $10 per person. It is the same price for adults and children except for those under 3. So my slope, whenever I see that word per, that's going to be something that happens over and over and over again. So each person has to pay $10, but there's no other fees. There's nothing else that we have to pay up front, so that is a direct variation situation. So looking at these graphs, let's see, this one and this one. Well, this one's going to be direct variation and this one's slope-intercept because this begins at 0, 0 and this doesn't. Here we got two tables. So this one, if I go back, it looks like it's going up by 6. So if I go back 6, that would be 0. And this is going up by 1. So if I go back 1, that would be 0. So that would be there. And this one, it's going up by 10. And this is going up by 100. So if I go back 100, this would be 0. But if I go back 10, it would be 25. So the intercept would be 0, 25. Now we've got two situations here. This says potatoes are on sale. $1 pound is $1.19. 2 is $2.38. So this is going up by $1.19, and the pounds are going up by 1. So if I subtract $1.19 and I subtract 1, 0 potatoes would cost us $0. Well, that makes sense. In this case, one ride is 4 tickets, two ride is 8 tickets, but you see we have an entrance fee here, so that's $5 before we ride any rides. So y-intercept would be 5, so that would make that slope-intercept form. How do you find the slope? The change in y over the change in x. And what is the value of x at the y-axis? 0.